Hi, and welcome to the 22nd webinar in 12D's training webinar series. My name is Lisa Stewart, and I'm the Marketing and Communications Coordinator here at 12D Solutions. 12D's training webinars showcase common industry challenges, taking a close look at industry best practices and how these can be implemented using 12D model software. The aim of these webinars is to upskill 12D model users and broaden their understanding of the capabilities of 12D model. We run these webinars regularly and record them for posting through our website and on YouTube. The first 21 webinars from this training series, as well as the first 23 webinars from our Industry Solutions series, are available on our YouTube channels if you missed those. During this live presentation, you'll be able to type your questions along the way, as shown on the screen, and we'll answer as many as possible throughout the webinar. At the end, I'll also read out some of your questions to the presenter for his insights if there's time. Today's webinar on snippets will be presented by Joel Alsop, who has worked in 12D model support and sales for Extra Dimension Solutions, our 12D distributor for New South Wales, ACT and South Australia, for nearly 4 years. Prior to that, he had nearly 20 years of experience in engineering with a variety of organisations within New South Wales. This webinar will take you through the basics of creating snippets in 12D model, then move on to some slightly more complicated aspects of snippets. Over to you, Joel.
Thank you, Lisa. Good afternoon, everyone, and thanks for joining us today on our Snippet Basics webinar. We're going to run through just creating a simple snippet and what snippets actually do. We'll look at parameters and auto parameters, and we'll also take a bit of a look at some of the pre-processor basics and some other little bits and pieces you can do with snippets. So what is a snippet? Well, as we probably know by now, it's a collection of MTF commands that you can save to an external file. It can do anything from create roads and curbs to do transitions and modifiers and all types of stuff. The advantage of snippets is that they're reusable. They can be used over and over again. So what exactly is a snippet? Consider this. We've got a speed hump. Now, at the most, you probably wouldn't bother modeling it because you have too many commands. You just don't bother. What if you could actually do all of that in a single snippet, which is a single command in the MTF? So a single snippet can be created, we can use it multiple times, and we can just insert it over and over and have 100 speed humps running down our road. But we'll come back to that one a bit later. So how do we create a snippet? Well, obviously we need our MTF. We need to create all our modifiers in the MTF first, and then we need a text editor. Something as simple as Windows Notepad is good, but a top tip is to use a text editor with syntax highlighting such as Notepad++, Notepad XML, TextPad, that type of thing. So we start off with all our commands in our MTF. Now here we've got a simple road cross-section. We're inserting the carriageway, putting the curb in and some footpaths and some landscaping, that type of thing. So the first step would be we actually create the modifiers in the MTF. We copy those out of the MTF into our text editor using the copy snippet paste into the text editor, and we save the file with the extension MTF snippet. So let's jump into 12D and we'll just create a simple snippet. So you can see here we've got our road. I've already created the left-hand side, which has got all the modifiers that we need. So we'll just open that one up for editing. And we see on the left-hand side, same as that screenshot, we're inserting the curb and the road, we've got a footpath and a couple of other things in there. So essentially what we need to do is select all of those modifiers, and if we hit the right mouse button, we've got our option here to copy, snippet, paste. Now there's a difference between copy and copy, snippet, paste, and we'll cover that a little bit later. So we copy that, come across to our text editor, and we'll just simply paste it in. There's our snippet. We'll do a save as. We shall go and put it into our project, and we'll just call this one fullroad.mtf snippet. Done. Now, things to note. Using the copy snippet paste is important because it changes the syntax for the start and end chainages. If we looked at the MTF, we would notice that it says start ref to final ref. Once we copy that into the snippet, it uses this SCH and NCH. Another good thing with snippets is add comments. You can't stress that enough. You'll create a snippet, you'll come back to it 6 months later, and you'll have no idea what is going on. So let's just jump in. So I've already got a comment here, which was copied across from the MTF. And we'll stick another one up here. Great road. Put another one in here. Great curb. Simple as that. And save it. Now, currently our snippet would only be correct on the left-hand side of the road. Now, if we insert on the right-hand side, we might get errors, have incorrect string names, that type of thing. And that's because the L for the left is hard-coded into the snippet at the moment. So if you have a look at our MTF command down here, we got design, and we're inserting a string called KLL. So that's curb lip on the left-hand side. Fine if we're doing it on the left-hand side, but of course, we're not going to do that. We're going to also use it on the right-hand side. So let's jump in, and we'll actually insert our snippet into our MTF. So we can close down the left-hand side now. We don't need it. Let's come over to the right-hand side. Grab our full road snippet. And we'll just run it. So there we go. We can see we've got the right-hand side matching the left-hand side. But, of course, if we have a look over in our plan view, our string names are the same. String names on the left-hand side are correct. String names on the right-hand side are incorrect. So how do we get around this? Well, we could have a left snippet and a right snippet, the way we would have done with templates. But snippets are a little bit smarter than templates, so we can do other things with them. Other things as well, what happens if we want to change the width of the carriageway? We might not want 3.5 meters. So like a template, we could use a modifier, we could edit the original snippet, we could have another template, or what would be really good if we can define the width when we actually insert the snippet into the MTF. And this is welcome to the world of parameters. So parameters basically allow users to pass values into the snippet. They allow user-defined values to be put in. Now there's two types. There's a parameter, which is allowing user input, and there's an auto parameter, which runs in the background and has no user input. The values can be passed directly to the modifiers, or they can be substituted into other mathematical functions and much, much more. There's different parameter types available. We can see here we've got the typical ones. You've got real, integer, name, which is a string name, text, which is just a normal piece of text, select, we can actually select an existing string. Choice, we can decide, we can have yes, no answers, we can select a layer in the MTF, we can select a model, we can check whether a tin exists. So what we would actually want to do here is we want to be able to change our road width when we insert the snippet. We don't want to have to use a modifier. So we're going to create a parameter. We're going to have it a real because it's going to be a real number, obviously. We're going to give it a name called width, and we'll just have a description, and we need to put a default value in. Other ones will do as well. What about the crossfall of the road? Generally you might have -3, but if you're living in Queensland, sometimes they do things a little bit odd. You might have -2 or -4, something like that. Same with our footpath. We might not want the footpath to be 1.5 meters. We might want to change that on the fly, and so on. So let's go back to our snippet. Put a few rows in here, and we're just going to put in some parameters. And you can see here as I'm typing, this is where the syntax highlighting definitely comes in handy. It helps sort of show what's going on. Parameters, we're going to call it, give it a name of width. It's a real number, and description. And of course we need a default value. I have another parameter here, which is for our crossfall. Again, just a real number. Description. And a default value. And finally, our footpath. Okay. Now, when we come down here, another thing I like to do in my snippets is actually tidy up some of these zeros. So when it comes out the MTF, it's to 8 decimal places. We don't actually want all those zeros in there. So we're going to do a quick find replace. Just going to get rid of all those zeros. Close that. There we go. Things are a little bit neater. Now we need to come down here. So we've created our parameter for the width of our carriageway. So where we're doing our insert for our curb lip, we actually replace the hard-coded value with our parameter. Same with our crossfall. And down to our footpath width down here. As you can see there, the case is very important. If you've used uppercase here, you need to use uppercase down in the actual MTF modifiers. We'll save that. Now if we come back in the right hand side here, we'll see we've actually got these parameters. Now we can change our carriageway width to 5. And apply that, we can see our road's bigger. We can push our footpath out to 5 metres. So it all works nice and neat. We can do all this on the fly. We could insert this same snippet multiple times if our road width changes further down. Now, as you notice, we've still got our left in here, still hard-coded in our snippet. So let's take a bit of a look at how we can actually fix that. So this is where we mentioned auto parameters. Now, we could put the left and right in as a parameter, so someone has to type in left side, right side, that type of thing. It gets a bit messy. What we can actually use is an auto parameter. Now, the simplest one is just substituting L and R, and that'll be based on whether it's in the left-hand side modifiers or the right-hand side modifiers. It makes it a lot easier. It means we can have one snippet that will work on the left side of the road, and it'll also work on the right side of the road. Now, a few of the auto parameters. Here's a few here. So we got auto left, right. We got the auto left, right using numbers, which is sort of your MX coding. And actually, that one's your MX coding. We got start change and end change. So you would have seen when we created the snippet, it had this SCH and ECH, which is short for name position modifier start, name position modifier end. We can insert the ref string name. So that's the ref string that we select in our apply MTF panel. We can insert the last character of the ref string name. We can insert the last 2 characters, last 3 characters, and more. We can insert the last 4 characters. We can insert the 3rd character of the ref string name. This is when you start to use your MX naming. We can insert the 2nd to 4th characters of the ref string name. We can insert the X to Y characters of the F string name. We can insert the name of the apply tin. So if you've got a modifier that uses the same tin that's defined in the apply function, we can use that same tin value. We can insert the hinge name. We can create a silent name grade in the background. We can insert the name of the design model from the apply MTF. And we can also insert project attributes. So to avoid manually typing our LNR, we're going to use an auto parameter. Now it takes the same format as a normal parameter with the $, the open brackets, the closed brackets, and it's just the underscore auto underscore LR. Now the underscore at the beginning isn't exclusive to auto parameters. You can create other parameters using the underscore, but generally we use the underscore for the auto parameters and your normal parameters don't have the underscore. So let's jump into our snippet. And we've got all these L's in here. So we'll replace them with a $. Capitals again. Auto left, right. Now I'll be a bit lazy. We're just going to copy paste. Save that. Come back here and apply it. And there we go. Now we've got our right prefix, suffix, right suffix. So we've got left-hand side, right-hand side. So we've taken care of the left and the right. Preprocessors. Now you might be wondering, what is a preprocessor? Well, it's tokens and if statements and lots of little programmy stuff in the background. So we can define a token that has a value. We can define a token that has no value. We can check if a value exists. We can check if a value equals another value. We can check if a value does not equal a value. We can do something else. We can also end. And we've also got go to and label, so we can jump around inside the snippet. Now, if we have a look in our snippet, we can see that our crossfall, the same crossfall is used to define three links. That's the front of our footpath, back of path, and the back of our landscaping. And they're all at 2% crossfall. Now, what if we've got a client that's got a slightly different standard, they want 1.5% or 3% or something like that? We could go in here and modify it 3 times, and that's a bit much. I don't like typing. We could create a new snippet. We could have the crossfall as a parameter, so we type the crossfall in every time we want to insert the snippet, which again gets a bit annoying. Or we could just define that crossfall once and pass that down to each modifier. So how do you do that, Joel? Well, I'm glad you asked me. We can define a token. Now, token is programmer speak for define a default value that does not require any user input. Tokens can be as simple as substituting values into MTF commands, such as we define a token called tok and it has a value. Or they can contain actual mathematical equations. So we can have our carriageway, we take our width value plus our shoulder, multiply it by 2, simple functions like that. You can use sine, cos, tan, and all those other nice geometric equations. So what we can do now is actually define the crossfall value once. We can define the token as path crossfall with a value of 2, and we can pass that down into our modifiers. Now, if we want to change that later on, we can actually just go in there, change that number to 3 or 4, and that'll automatically pass down. Tokens can define other values as well. It's not just restricted to numbers. We can define text. So on all our modifiers, we've got absolute, extra start, extra end. We can replace all that with a simple token. Tokens as well they don't just have to be a single word. You can use dashes, underscores, numbers, letters, that type of thing. So we'll go in there and we'll create a few tokens in our snippet. So I'll put our tokens down here. Now tokens all start with the @ symbol, and we have def-tok going to our path crossfall first. It'll have a value of 0. Now again, we can add comments in here so we know what's going on. Down in our snippet where we've got all these 2s, we can now replace those with our crossfall token. And we'll define the width of our back of nature strip here. So again, at def-tok. Let's put in as 2.8. And finally, we'll take our absolute, extra start, extra end. Now, one important thing when defining text is to use quotes at the start and the end. That preserves any white space between the words. If we didn't have the quotes there, it would concatenate it all into a single text string, which would be bad. So we can grab this token here, come down here. Grab our ASE. Remembering all the brackets. And save that away. Now, what we've done here is actually all just sitting in the background of the snippet. If we come back in here, it hasn't actually changed what we see on the snippet panel. Tokens are all defined in the background. We're sort of defining default values inside the snippet. These ones aren't taking any user input. So we apply that, and it's all fairly much the same. If I come in here and change this value and save that, if I reapply, you'll notice that that EXR string actually gets wider. So that's tokens. If statements. Now this is where you start to get a little bit programmy. Essentially an if statement can do a few different things. It can test whether one value equals another value, and if it's true, we can do something. Often you'll use this with the choice parameter. So you might be doing something simple like, do we want to add a curb, yes or no? If the value is yes, then we'll go and put our curb. If the value is no, then we'll actually ignore it. The way the snippet will work, it'll come down here, it'll test, do you want to add a curb? Yes, I'll add the curb. If we actually select no, it'll come down here and say, well, the value curb doesn't equal yes, so I'm going to skip over all that and not actually create the curb. Come in here, so we put in our new parameter, our choice. I'm going to simply call it curb, say choice parameter. Curb, and we define our two choices, yes and no. The first value will be the default, so when we open the snippet panel, it'll always default to yes. We come down to where we're actually creating our curb. Now we need to put in our if statement, so at. If our value equals something, so if our curb parameter equals yes, then go and create the curb. And we need to end the statement. So if we jump back into 12D, you can see we've got our new parameter here. We're creating a curb. Apply that. It's exactly the same. If we turn that off and say no, you'll see that we no longer have a curb on this side of the road. Yep, so simple as that. Simple yes, no. You could have different curb types in there, so you could be defining, do you want a curb and gutter, do you want a curb only, do you want a dish drain, roll curb, all that type of thing. Now, what if the statement's not true? So what happens if we select no? Maybe we want to do something else. We might just want to put a verge in, a grass verge or a gravel verge or something like that. So we can do that. So at the moment we're saying if the value for curb equals yes, do something. Otherwise, if it's not yes, we can do something else, and that's by using the simple else command. So we can add in a verge, so where we don't have a curb, we can put a simple verge in. So back under here, after our curb, if we put else, insert, design, EV, we want to use the auto left right. Give it a color of rock. Now we'll just give it a width of 1. And a crossfall of -2. And I'm going to be a bit lazy here and just copy the back part of the modifier. Whoops. Copy that and paste that. So what we're going to do if we create a curb, we're going to create a curb. If we decide not to create a curb, then we're going to put in this extra bit of verge in there. back into 12D. Turn that off. And you'll see it's actually created this bit of verge on the side here, this little brown strip. So, nice little if statement, nothing to be scared of. You can see there they're quite simple. It's a couple of extra lines, they're very simple commands. They can be a lot complicated, but that's for another day. So what else can we do with if statements? Well, we can simply test whether a value actually exists. So we might put something in there that's optional, such as the shoulder. So rather than having a choice parameter there that says, do you want a shoulder, yes, no, we can actually just ask for a value for the shoulder and we can make it optional. Now the way we do that with our parameter, the parameter is exactly the same, except rather than a default value, we put the word optional. So that means that we don't have to have a value in there. Then further down we use our if statement and we actually check whether a value exists. If there is a value for shoulder, insert the shoulder. If there's no value for shoulder, just create the curb lip. So I'll insert our parameter. I've called it shoulder. It's a real value because we're looking for a number. And we're going to make that value optional. Now down where we're creating a road, we have to use our if statement to check if the value exists and if we need to create the shoulder. So in this case, we've got if val, so if our value exists, it needs to be lowercase. If the value exists, we're going to insert a shoulder. Now I'm going to be, rather than have you sit here watching me type all that out, we'll just copy our insert command. So if we want a shoulder, we're going to put in an edge line, which will be our road width. We'll have our crossfall. And then we'll put in our KL, which will be at the same width as we define our shoulder. Now if we don't want a shoulder, we're just going to create the lip. So at else, just create the lip, and we'll end the command. Simple of that. If there's a value for shoulder, put in an edge line and the curb line. If there's no value for shoulder, just put in the curb line. Save that. Let's reopen this snippet. Now you'll see there, here's our shoulder width, and it's grayed out. So that means it's optional. Like every other panel in 12D that has optional values, it's grayed out and in italic. So if we hit that, just creates our regular road. If we put a value in here, 2, we actually get our shoulder on the road now. We can turn our curb back on. And there we go. So we've got our lane, we've got our edge line, we've got our shoulder. Might be a bike path, something like that. If we take it out, it's optional. We don't need a value. And the shoulder goes away. Now, there's some other little parameters we can use which help users to understand what's going on in your snippet. We can provide some information and we can display values in the MTF. So the first one, info. Well, actually, we can type in some information about what our snippet actually does. So it's always nice to put all this up the top. Simply info. Yeah. And we use the display parameter down here. We might want to display the actual width of the road. And we might want to display whether we're using a kerb or not. Save that. So reopen our snippet. If we come down to our info button down here, you can see there's some information in there about our snippet. Now you can put multiple rows in there. So we could have another row. Info. Save that, come back on the info button. Now we've got the extra information there. Very useful so that users can see what's actually going on with your snippet. You can put hints in there about what they need to do, what they don't need to do, that type of thing. The other one you'll find now, if we just apply that, over here in our modifiers, we've now got some details coming up. We can see the width of the carriageway that we're using. We can see whether or not we've got a kerb turned on. So I can turn the kerb off, go no, and apply. And you'll see up here it now says we're not using a kerb. So nice and simple, as you're reading through the MTF, you can actually see what values are being used for that snippet without having to open the snippet panel. And again, that can be as big as you want it to be. And that's our simple road snippet. Yep, so that took us all of 20 minutes or something like that. We've got a nice beginning of a little snippet here again. You could have different types of kerbs in there. You can define a lot of your kerb dimensions up here and all that type of thing. It's all very nice and simple. Now, back to our speed hump. So remember this thing here. As we said, who would model a speed hump? It's just too many modifiers, and especially if you've got 20 of them, 100-lot subdivision. So what we'll do, we'll actually go ahead and we'll turn it into a snippet. Makes it a lot better. We can just put them in down the road wherever we want them. So the first thing we need to do, of course, is come into 12D. We'll close down this side here. You'll see over here we've actually got the left-hand side of a speed hump already created. So if we open up that MTF, we have a look in the left-hand side. We've got all these modifiers in here to create 1/2 of a speed hump. Now, who wants to do that 20 times? Not me. So basically what we do, we grab everything from here down to here. Again, snippet, copy, paste. Let's come over to our text editor, we'll create a new file, and we'll save that out. Done. Again, we've got the syntax highlighting and everything like that, which is nice and neat. We'll go through, we'll get rid of some of those zeros. Remembering, I like to make it nice and neat, so let's do a quick find and replace on all our zeros. That's that. We've got a couple of extra ones out here. Oops. Place all them, close that. Now the other things we had, so we had the absolute, extra start, extra end. Now thankfully in TextPad I can run a little bit of a macro that'll just replace all that for me. Got a couple of other ones down here. We're not using the absolute, we're just using the extra start, extra end. So I'll just have to do those ones manually. And of course, we actually need to define those def docs up the top. So let's come up here and put them in. Now we can cheat a little bit. We can come back and copy this one from our previous snippet. Paste him up there. And we can save that away. Now, when using the copy snippet paste, all the modifiers will actually have the same start chainage and end chainage, but we may not necessarily want that. With our previous road snippet, yeah, we wanted to run from the start to the end, but for a speed hump, it's going to be over a set chainage. The speed hump's not going to run for the entire length of the road. So in the same way with modifiers, we've got smart chainages and all that. We can actually set the snippet so we can end relative to the start, we can start relative to the end, we can end before the start, and all that type of thing. So in the MTF, we actually used a chainage alias to define the speed hump extent. So we had the speed hump was 10 meters long, so I created an alias that had a start chainage, and then the end chainage was 10 meters after that. And the ramps were then defined to commence before and after the extents. In a snippet, we can do the same thing, but it's a little bit different, because the modifier chainages in the snippet are actually relative to the start-end chainages when you insert the MTF, when you insert the snippet in the MTF. So as the snippet start-end chainages in the MTF will be used to define the extents of the speed hump, the ramps will be defined to extend before or after the snippet chainages. But that creates a problem, because when we insert the snippet, the speed hump links don't exist before and after the snippet extends. So the links also need to be extended -1.5 before the start and 1.5 after the end. Confusing? Let's have a look at a little bit of a picture. So we can see here, this is our snippet start. We're going to insert it, and that's going to be our relative chainage in the snippet of 0. Our speed hump is going to be 10 meters long. One ramp is going to start 1.5 meters before 0, and the other ramp's going to end 1.5 meters after. So this is how our snippet will look. We'll have a start chainage, we'll have an end chainage, and we're going to start the links and the ramps before and after. So our links need to be inserted from the start chainage back 1.5 meters and from the end chainage beyond 1.5 meters, and the ramps will start at -1.5 and end at 0. The other ramp will start at the end chainage 0 and end 1.5 meters past that. So let's do all that in our snippet. So there's going to be a little bit of typing to get through here. So insert absolute. So we need to insert all our links. So any of our insert absolutes need to extend for the full length that we need. So we need to start before the snippet, and we need to end after the snippet. Same down here, -1.5, 1.5. It's also nice to space these out a bit so it's a bit easier to read. Now we've got our ramps here. So remember we were saying that one ramp will start, the approach ramp will start before and finish at 0, and the depart ramp will end and finish after the end. So this one here will actually start at -1.5, and that ramp will actually end at the start chainage. The departure ramp will actually start at the end chainage, and it'll end 1.5 meters after the end chainage. Again, modifying our curb, so we can get a bit lazy, use a bit of copy paste. Make sure we're creating all our links for the full length that we need. And the same with our ramps. So we need to start 1.5 meters before the start. We need to end at the start. The departure ramp will start at the end and finish 1.5 after the end. And we can't forget our shape creation. So our shape needs to be created for the full extent. Now with a bit of luck, we'll come down here. So let's just drop this on down and let's put our snippet in. Speed humped, we're going to do typed, we're going to start at chainage 70 and we're going to end at chainage 80. So that's our 10 meter speed hump. We'll apply that. And you'll see we've got our speed hump. So there we go. Here's the speed hump that was using the modifiers, and we've got our speed hump using the snippet down the road here. So you're probably thinking, why don't we just start the ramps at 0 and end the ramps at change 0? Well, that's a good question. If we did this, we would still need to define the 1.5 meter length of the ramps. So our modifiers will look something like start at change 0, end the ramp at 1.5. Departure will start 1.5 before the end, and it'll actually end at change 0. So you could do it either way, but once the method I'm using will become a little bit clearer later on. So far, our modifiers are being applied from a start chainage to an end chainage. So we're actually defining the length of the speed hump by putting in a start chainage and an end chainage, which is perfectly fine. But again, you know how much I don't like typing, so it's all a bit clunky. I want to just put in one value. So we know our speed hump is 10 meters long, so can't we just define the start chainage and then create everything relative to that? Of course we can. So coming back to look at our picture again, we had these values in here. So we've got our 0 is our start. We know our 10 plus 1.5 is 11.5. 0 minus 1.5 is minus 1.5. So why don't we go through and actually define everything relative to the start chainage? Sound a bit simpler? It means only typing in a value once. So let's jump back into our snippet and we'll change a few of these values. So now we've actually got all our ECHs will be changed to SCH and they'll all be 11.5. Grab that one. 11.5. 11.5. Now the ramp, we need to do something a little bit different because our departure ramp will actually be 10 meters. Yep. So assuming we've got everything, we can come back. We reopen our snippet, and I've missed one. Start change, start change, start. Let's clear that out. Still looking for an end tonnage. Bear with me for a second. There we go. Now we can see start end mode is grayed out, so we just need to define the start of our speed hump, which we want to change 70. We'll apply that. And there we go. So you can see if I select this modifier here, you can see our start chainage is at chainage 70. It's creating the speed hump 10 meters long, and it's doing the ramps before and after. Yep, much nicer. Back to auto parameters. Now, some people may have already noticed that I haven't gone through and tidied up the L and the R and everything like that yet. I'm going to use another auto parameter here as well. You'll see with some of our link names, they've got the L for the left-hand side, and they've got this S20, which is coming from the ref string called RS20. So we're using the last 3 characters of the ref string to create unique string names on our speed hump. Now, the good thing is we can actually concatenate all these auto parameters. So we can use the auto left, right, and we can use the last 3 digits, last 3 characters of the ref string. We can concatenate them together. So our link name now becomes HMPA, auto left, right, and whatever the last 3 characters is. The reason we do that is so that this snippet can be used on another road. So if we used it back on our road RS10, the strings are going to come out with S20 on them, but we don't want that. We want them to come out with S10 on the end. Now, another tip of the day here, make use of find replace because it helps avoid typos and really, shape commands. Who wants to go through and type all that in manually? Definitely not me. So let's jump back into our snippet. And you'll see here's all our LS20, 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 LS20. Let's go up and replace LS20. Let's replace it with auto left right, and last 3 characters of our ref string. So we do replace all, and there we go. So this snippet can now be used on the left-hand side or the right-hand side and on any other reference string. So let's jump in and put this on the left-hand side, the right-hand side, sorry. Modify right. Put it in at chainage 70, like that. And we broke something. We'll come back to the right-hand side. Let's keep moving. Now, we've hard-coded in the actual length of the speed hump at the moment. So obviously, 10 meters is a good length, but we might have, again, different councils, different clients have different standards, and the ramp length as well. Maybe some councils might want 2 meters, 2.5 meters. We might need to make it flatter when you've got buses driving down the road. So we can define those as user-defined parameters, declare them as user-defined parameters. And we can also put in some simple tokens here. So rather than having to work out the mathematics and all that, we can actually put in some simple formulas that will calculate the start and the end for us. So back up the top. So on a parameter for the length of our ramp, we'll put a default value of 10. .5, and that one should actually say length of hump, not length of ramp. Come down here with a couple of simple def talks. So we can define a value called start. That is simply going to be 0, being the start of our ramp, minus the length of the ramp. And we want another one. Define a token for the end, which of course will be the length of our speed hump plus the length of the ramp. Now what we can actually do is these values in here, so the minus 1.5, the 11.5 and the 10s and all that, we can actually replace those with the values of $start and $end. Not forgetting our shape. Our start, so anything that's minus 1.5. Our end. And the last one in here, $length, replacing the 10 meters because we know that the length of the ramp is going to be 10 meters now from our user parameter. And this one will actually stay at 0 because everything's still going to be relative to that 0. Now, that error that came up on the right-hand side, which just dawned on me, is because we've still got this hard-coded design curb lip left. So we take that L out there, put in our auto left-right. Save that, make sure I haven't missed anything else. So let's come back in here. Here we go. 10, 1.5. 10 and 1.5. Okay, on those. There we go. And there's our speed hump working on both types. Speed hump on both sides of the road. So took a little bit of struggle, but we got there. And so now that's a speed hump. We can insert that just multiple times down the road. We can change the length. So let's put in a 15 here. And you can actually see that our left-hand side is longer than the other side. So what are a few other things we can do? Well, to finish off, let's just look at a couple of other little things. Jump back in here on the left-hand side. Got a couple of snippets prepared a little bit earlier. So some extra stuff. Now, obviously, at the moment, all of our speed humps are going to have the same string names, and we probably want some unique string naming. So what we can actually do is add in a sequence number. So that'll add an extra character into the string name. We've still got a speed hump length and ramp length and all that. Let's insert this one, chainage 110. Just apply that. Now I've got speed hump there. I'm also using a bit of a map file, so we get some nice little line marking happening across the top of the speed hump. We're skipping this through. Now, what else would we like to do? Well, we might want to add some kerbs in, or, piano keys. Who wants a bit of line marking in their speed hump, yeah? Let's jump back in the left-hand side. Again, here's another one I cooked up earlier. Again, we've got sequence number, we've got the length. Let's just jump down the road a bit. Apply that. Might help if we actually put a, put a value in. There, it's a plain looking speed hump. We can throw some kerbs in, like that. And we can put in some piano keys. Spin around, there's our piano keys. Nice simple line marking. All the type of stuff that if you didn't have snippets, you just wouldn't be doing any of this in your MTF. Yep. And that's it. Thank you very much.
Thanks, Joel. We're quite close to time, so I won't take any questions live just at the moment, but we'll get back to everyone by email soon. The recording of this webinar will be available in coming days through our website and our YouTube channel. Our next two training webinars are title block files in the drawing register on the 26th of April and components on the 10th of May. So do keep an eye on our website for details of those, as well as our upcoming industry solutions topics. We'll also continue to keep you posted through email and social media. If you need to contact us in the meantime, just pop onto our website. That concludes our presentation for today. Thank you for attending, and we hope to see you at future webinars.